Yesterday, March 30th, 2025, we saw a very large area of severe weather impact the United States, from regions up here in Michigan all the way down to eastern Texas and Alabama, Louisiana, and a very large area of severe weather potential. We saw this come to fruition, especially in the Midwest. We saw a lot of wind reports, some of these significant. Here's our storm reports from this day as well. You can see the black boxes are severe weather wind reports. You can see 700, about 700 total reports here. These are still coming in as the day's been going on, so I do expect this to increase. Large hail reports down here in Missouri and Arkansas, and lots of large wind or very strong wind reports, as well as a few tornado reports, less than we expected, but I mean, severe weather did happen and it was very well forecast. We can see here in particular in the Midwest. These are some maps I made, but you can particularly see how I like. You can see how many wind reports there were here in northern Indiana, and just the broad region of hail reports as well. So it's a really nice map to look at, honestly. You can see also how well these risks were placed, where most of these storms started right on the boundaries of the enhanced risk, really. So very well placed risks here by the SPC as well. So I'm going to be going over some of what really happened, some of the radar loops as well, just so we can kind of understand, what was our situation like, what caused this severe weather event, and just some various ideas. And this did cause damage. Actually, this is my Twitter here. I posted a few pictures here at Valparaiso University, and we had some large metal things. I don't really know what these are. I call them metal sidings. Come off our chapel here. You can see that is still there right now, and some pretty large branches down. Although in all seriousness, not very thick. But there definitely was this damage. We had 80-mile-an-hour wind gusts reported at our local airport as well. And other regions across the region also saw this extensive wind. So let's go into the meteorology of what happened. First thing I want to do though is really show you just the large scale of this setup here. So I'm going to go here to the SATRAD. It's just the radar, and this has the all of the reports, or not the reports, but the watches and warnings on it. So you see a lot of colors come up. You'll see the radar loop here, and immediately you'll see that we get storm initiation right here around 17Z. That's probably the best time to say. You get this line of storms that fires right there, around 16Z. You get this line of storms starting to fire there in Missouri. That is going to be, again, 11 a.m. Central Time. And pretty quickly after that, you do see this tornado watch get issued right there at 12, right at noon. And immediately you start getting severe warnings along this line, tornado warnings soon after. Chicago was put in a tornado watch as well. And we just let this loop play out. You can see a very broad, actually slow this down a little bit, a very large area, especially a lot of tornado warnings down here. Let me zoom that back because I forgot to really mention that. Lots of tornado warnings down here in particular, so definitely enhanced tornado threat existed down there. You can see this wind threat really quickly developed into a very, very well-defined bow here. You can see if I take off the watches and warnings. I'll go back to the Midwest in a second. But let this loop play out again. Various tornado warnings along the line. You'll see some in Ohio. I think a few even down here in Mississippi and Alabama, but a very large area of severe weather potential throughout the day. And this is getting into overnight hours here as well. But you can see we definitely had multiple lines of storms, lots of large hail. Louisiana in particular, you can see lots of tornado warnings here as well along this line. At this point, we're getting into the next day. But the general idea remained the same. We saw a very linear storm mode over much of the region, especially in the Midwest, and multiple storms being able to fire up. A few embedded supercells, especially more in the south as well. And those were often a little bit more on the hail side of some of the more southern storms. Let's look here at more of this Midwest sector here. It's also loading as we go this page, but see the idea. You get some early morning convection, but not very widespread. So it doesn't help to hamper that severe threat or anything like that. And then you get immediately these storms here firing all over the place, and very quickly here again, the bowing out becomes very apparent. This is probably some of the peak wind speeds, if I remember correctly. You can see very well here the bowing of this storm system, especially in this section right here. And that is where we saw our strongest reports, right in that little corridor there. So I just want to point this out. I thought the radar loop is very interesting, but now let's get into the actual meteorology. So I'm taking this from model runs a little bit, just so you can kind of understand what this system looked like the day of. I'd probably go back and find some observed soundings, hopefully. I do know some of the stations have stopped doing soundings as of recently, so it might be a little bit difficult, but I believe the Midwest has still been pretty consistent with observed balloon soundings. So here's our 9Z setup, or the 9Z initialization here from the RAP model. And just an idea here, you can immediately see that our troughing here, a little bit of a jet streak at the base of this trough over Oklahoma, Texas, kind of right by that Red River, and just pretty broad troughing there. Linear temperatures is obviously pretty cold aloft, not super cold though, not like we saw last time up here in kind of the Midwest. And you'll see this moves on with time. Vorticity, a little bit of, yeah, definitely vorticity involved as well. Uh, at this point, we have a surface low somewhere around here, I believe. Oh no, excuse me, I was way up north. Sorry about that. But yeah, I guess vorticity advection was we already had a surface low ongoing. That makes sense. This was not rounding, getting off the Rockies. Excuse me, messed up where my surface low was. Let's look at 850 millibars now. You can see we have, again, pretty broad low-level jet increasing throughout the afternoon hours, which is a little bit weird. Semblance of a shortwave right here as well. Looking at 700 millibars, very similar story. A very much embedded shortwave right here to force a lot of these storms, and definitely this enhanced flow at 700 millibars is not going to, it's not going to hurt the severe threat at all. Let's look at our temperatures now. Even at 9Z, that's going to be 4 a.m. in you can see very widespread southerly flow over Illinois and Missouri. Looking at theta E, this is very unstable air mass. You can see moisture. We had 60s dew points at initialization here in the Midwest. That's the wrong sector. Midwest sector is what I want. 60s dew points, and this was intended or expected to increase throughout the day here as well into the mid to low 60s here. 63 is pretty widespread, but some regions seeing more rich moisture, especially with southern extent. At initialization here, you even have pretty high 60s with some 70s down here in Texas as well. And this would continue throughout the day as well. Very good moisture down here in Texas and Louisiana. When we saw that the increased tornado threat at the end of the period, that was likely due to a lot of these storms existing. Or not storms, excuse me, the moisture really being pretty prevalent in that region as well. So again, let's first focus on the Midwest. That's honestly the most interesting in my opinion. Let's look at our surface-based cape from the RAP model as well. You can see a broad region of instability, but this pretty intense instability, especially for March. This is 2,000 joules per kilogram, pretty good. Broad blues, the blues are the 1,000 joules per kilogram, and that again, remember that cape is a measure of instability. The bigger the number, the more the parcels, the air will rise and form into thunderstorms. So don't forget that when I talk about instability in cape. But yeah, lots of instability was very much prevalent. The cap was gone. The air mass was unstable. And remember that storms are forming right about now in this region of instability here. That was very much the truth. Our surface low, again, if we wanted to place a warm front, cold front, you can see this warm front gets pretty far north into Michigan. And a little bit colluded cold front as well. Actually, this is a little confusing as well. If you go back here, because there is this, there are kind of two fronts. I would call the main cold front back here. But there's kind of a little bit of maybe a convergence band here. You can see it very well on the RAP. You can see how the winds are pointing right toward each other. Let's look at mass convergence. You can see mass convergence is definitely increased right there. Let's actually connect this to our radar. This could have been what formed some of these early storms. A little bit hard to say. Maybe some of these later storms as well. That could have been a big reason why we saw a very quick transition to linear mode, is because we had all these storms firing. Let's look at 3 Cape as well. The low-level Cape was pretty maximized in some of these regions, but the issue was storm mode. That was the primary issue. If we'd seen a more discrete environment here, we definitely could have seen more tornadoes. However, due to the upper level forcing being so strong, you can see all of our jet maxes are at each level are basically maximized here. The storms very quickly became linear. Here's our bulk shear vectors as well. Storm motion here. And if we imagine that our boundary is somewhere like this, it's a bad color choice actually. Somewhere like that. It's also a bad line, but it looks perpendicular, but these storms move very quickly. This front in particular is also moving very fast. This could have been also just an issue with how the storms fired. Sometimes that happens, but the early storms that fired, as you saw, very quickly were linear. I mean, honestly, upon initiation, they were linear. Upon, the moment they form, they are a line of storms immediately. They're giving plenty of those characteristics of that kind of storm. Yeah, very quickly transitioned. Any of these storms ahead of the line just immediately engulfed. Maybe a few of these cells ahead might have had that brief tornado risk or whatnot. I'm trying to see if there's a few tornado warnings ahead of the line, but it doesn't look like it at all. Apart from maybe a semi-discrete cell somewhere around here, I believe, but this was, again, still embedded in the line. The real discrete risk ended up being more south. These southern storms. Let's see if I can move my sector down at all. Let's see here. Move forward time. And I'm trying to really show this because a lot of these storms, yeah, here you go. Some of these storms were more on the discrete nature here. We take away the watches and warnings. You can see more discrete supercells in here. But these are mostly hail producers. At a certain point, a lot of these were tornado warned, and you can see kind of the supercell outbreak thing here. That's a lot of tornado warnings, but you can see all these tornado warnings across the line. Semi-discrete cells, but up north we definitely stayed more linear. Again, likely due to just the stronger storm motion vectors in just the environment. We'll get some soundings in a second, but the environment was very much conducive for just linear storms. And if the linear storms formed, they would continue and basically make just a massive windstorm. That is what we saw. I do think there was some potential for discrete cells, but in particular, this was mostly a wind-based environment. Here's significant tornado parameter. You can see not very elevated. Supercell composite as well. Did not say very elevated. That was more to the south where we saw those discrete storms. But in our region up here, we just saw a very quickly transition to that linear mode. And a little bit uncertain looking at our surface, and like if you want to analyze the surface here, it might have been just due to this very quick first front, how quickly that moved off. Let's look also at our convective aligned model, especially the HRRR in the morning. You can see quickly, the HRRR actually gave a little bit of a confusing look here. Initial storms in this kind of bow, and then a second round almost. But you can definitely see, again, very much a linear system, but you can still see that supercell event kind of down there in the south. Or not the south, but regions, more the southern region there, with the updraft helicity swaths certainly being more on the southern end. But we did see the increased wind gusts. We're more with the northern extent here. Some of that harder, the bigger punches were in the northern mode. This was true for a lot of the HRRR runs of that day. Fortunately, we can't go too far back, but you can see here's the 12Z HRRR as well, just that pretty well-defined wind gusts in the more northern mode. This one did definitely show it off very well at what occurred. He had that initial storm coverage right there about 16Z, 17, about a little bit less. The real life scenario actually went a little bit faster, I believe, than the HRRR here. No, it still looks pretty accurate, actually. In all seriousness, yeah, very accurate look here, but definitely the punch was more in the north again, and still the updraft helicity swaths were still with more southern extent. Well, you can see a very broad region of that rotation, especially right there over Chicago Metro as well. So, but just the general idea of this is that the more discrete storms definitely stayed to the south. Now let's finally look at some sounding, because I've been kind of itching to do that a little bit. Let's look at our environment with those first storms. I'm going to take, let's see, where's our front? And they can be a little bit less defined with the RAP model here. Let me take a sounding right here, just right in that kind of bullseye of Cape. We'll also take some 20Z right ahead of this line. This line was somewhere around this vicinity at the time. Not near Valparaiso, actually. Here's that southern extent. You can see pretty large, discrepancy. A pretty fat Cape, as you'll call it. 3 Cape was pretty nice. 69 joules per kilogram. Not super impressive, but still there. D Cape here was 817. But in all seriousness, usually that's more impressive for these big wind events. When wind is the main threat. 817 joules per kilogram of downdraft Cape, though not super. I mean, that's still pretty good amount. I'm looking at a number. I'm used to seeing a little bit higher sometimes. This one, wow, D Cape wasn't even 300 at this location. This one had more of a lot larger 3 Cape. Interesting. So the environment in these forecast soundings was a little bit confusing with it, and this does look to have been more of a mesoscale, how do the storms interact kind of day, where a lot of these storms in particular, they just became linear immediately, and that was what happened. There wasn't an opportunity for discrete development because of those early linear storms. They just jumbled up too fast, and downdrafts began to dominate the storms, and that's just what you saw. You can see our soundings here. The photographs in particular, not super impressive for tornadoes either, especially considering how veered our wind vectors were. If we look at the surface winds, especially, our better flow is in a very narrow corridor right here with southerly flow specifically. That might be a reason we didn't see nearly as many tornadoes other than spin up QLCS tornadoes. A lot of these vectors were very much veered a little bit southwesterly, something like this. You can see some of these vectors, especially, and back here as well. This region also, those storms I believe stayed more so elevated for a lot of their lifetime, as indicated by the major coverage of hail. But there definitely were a few tornado reports in this region as well, and that was where you saw those supercells. So that's kind of what we see in the Midwest. Again, there's not as much to talk about anymore. The moisture was there, the temperatures were there, and the instability was there. It's just that really a lot of the factors were there for tornadic environment. However, these storms just congealed so quickly. There was so much forcing that I think so many of them formed. We were so uncapped at that point. The storms just quickly turned linear, and that was how the day went. The southern mode. Let's move down to there real quick as well. Let's just see what our let's get a regional one here. We're paying attention more. Trying to look for a good sector here. I do apologize. Let's go here. And we can see some of our earlier storms. Let's see. This might take a little while to load, fortunately. There we go. So we do some storms. It looks like they didn't, their coverage didn't really occur where you'd expect to be over Arkansas. And that's kind of might be a good reason why we didn't see really any severe reports in this vicinity. Despite these rather deep convective storms here, they didn't become too severe immediately until later. And then that's when you're getting your Boeing line segment right there. And that's, maybe some wind reports. There's probably some still to be seen so far. The environment down here also, let's check that out. MU Cape. Definitely better storm motion vectors, but also very slow moving storms. That might not have helped them escape any cold front, and granted, this cold front was moving very slowly, but the lack of very intense forcing down here was probably a big issue as well. Here's 500 millibars, and over this broader region, we're not seeing super intense 500 millibar flow. Nearing 50 knots at some locations, but still not super impressive for severe weather down here. Just considering just the flow wasn't really intense. That's not where the main trough was. And that's probably a big reason why I saw a dampering in severe weather threat down here. Apart from the QLCS that eventually occurred, that was when your severe threat really ramped up, was when you got this big line of storms, likely just from the north as well. Well, a little bit of congealment eventually formed that. More in the south here in Louisiana as well. We definitely saw more tornado warnings, but multiple embedded. Look at all these line segments. These are actually beautiful. It's a very good showing. Here's a Boeing line segment. You can really see the idea of what a Boeing line segment is. It's where you bow out in front with that kind of gust front. There's three of them, very well defined here. Very impressive. I like this radar signature quite a lot because it really shows what a Boeing line segment is. But or a bow echo, as you might also hear it called. So just an interesting weather day as a whole. The instability was here, and that probably, again, that likely led to more storms forming, as we saw these very intense storms that eventually became downdraft intensive. Some elevated storms there too became downdraft intensive, formed that all this Boeing line segments, and have moved on into today as our current radar loop right now. But yeah, so that's the general idea of this system. SIGTOR, it's not the best parameter, but you can see it definitely got maximized in this region, kind of near NWS Paducah. Supercell Composite as well definitely got maximized here, and that's where we saw those supercells really fire, was in that region. If we look here, you can see those multiple supercells there. Move forward with time there again, eventually becoming linear. But you can see there was a very, very well defined right mover right here as well. How it's very much different from the rest of the line. All those supercells there, but eventually they would become part of the line. Again, forming that QLCS setup, quasi-linear convective system. Those are what you typically get in the Midwest for a lot of your severe weather days, where you just end up with that line of storms. You can get tornadoes along them. They can be violent, very much can be violent, but you do get those tornadoes along the line. So that was what we saw a lot, basically across a very broad region, but nonetheless, a very potent severe weather day, especially over in northern segments. We really saw everything that you expect to see from severe weather. Tornadic storms here, elevated storms maybe down south, I mean, Boeing line segments all across the line. A very impressive severe weather day, and definitely something you can learn from if you're trying to learn more about weather. So with that, I think that's a good place to stop this. Again, if you have any questions about what I say or any parameters that I talk about, please leave a comment. I'd like you guys to learn about weather. If you don't understand what I'm saying, I'd like you to understand what I'm saying if you're confused. So yeah, that's me it for this video. So again, thank you all for watching. If you have any feedback or anything, let me know. But that's about it. So thank you for watching, and I'll see you all next time.